Hi James, this is the last part of what I'm going to do on sequences and sums and recursive sequences. And I'm just going to do a few examples to show how to use the graphing calculator to calculate out the values. So the first one I'm going to give an example of is question number 5. That was the sequence -1 to the n plus 1 power times n squared. Okay, to show how to do it, generally you have to go to the list menu, go to ops, and then get this sequent function here. And then you just write in your sequence. So our sequence was -1 to the n plus 1 power. Here it's coming out as x, but that's not a big change. And then we have n squared, so we'll have x squared. So that's our sequence. And then we have to put in some additional defining features. So we're going to be indexing x. So we put x here, and we're indexing x from 1 to 5, meaning we're going to calculate the first 5 terms of the sequence, and then the last little bit here is just you put a 1 there to indicate that you're stepping in steps of 1. So it'll calculate the first term, the second term, the third term, the fourth term, and the fifth term. Okay, so that should do it. Let's go ahead and see what we get. Okay, that turned out right, and that was the answer we got, which was 1, -4, 9, -16, 25. So that corresponds to the answer that we got. Actually, I think we should do one more of this series just to sort of show another feature of the calculator that's pretty important. So that I'll go ahead and do number 3. So again, we go back to the list menu, ops, sequence, and number 3 was n over n plus 2. So we'll put in our sequence to be x over x plus 2, x over x plus 2, and again we're indexing x, and we're calculating the first 5 elements of the sequence, and we're going from 1 to 5, that is, in steps of 1. Okay, let's go ahead and do that. So you'll see there we ended up getting a lot of, I'm sorry, I didn't mean to do that. We're getting a lot of decimal values there, which we don't really want. So in order to fix that, we have to go to the math menu, and we hit this frac function up there. And that gives us this answer, previous answer, and we're going to compute it in fractional form. And there we get it. And I also wanted to show you that if you use these arrow keys here, you can scan through the parts that aren't shown on the screen initially. So the answer we got was 1/3, 1/2, 3/5, 2/3, 5/7, and you'll notice that that does correspond to the answer we got for number 3. Okay, now moving on to the next part, recursive sequences. Let's do 21 for that. For recursive sequences, you really need to use another menu, or it's most helpful to use another menu part. So you have to make sure you're in sequence mode. So first you go to your mode key, and then you come down and put in sequence here. And then you go to your y equals menu, and you put things in here. So where it says u to the n, you put in your function. So let me see, what one are we going to do here? We're doing 21. So they told us that our input function for this, a sub n, was going to be 3 plus a sub n minus 1. So we'll go 3 plus, and now we have to put u, because we've got a u here. So we go second u to the n minus 1, or u sub n minus 1 is what that means. Okay, so that is it, and then we have to just put in our first term. They gave us a sub 1 to be 2, so we're going to put that in here at that point. And generally you don't mess with the n minimum up here. You might have to mess with it in certain situations, but for this point we're not going to mess with it. I'm sorry, I think I might have to sneeze. No, I don't have to. Anyway, we go to table now. And we see we're not interested in when n sub 0, because that's not part of what we're looking for. So we'll go to n sub 1, and we see that we get the values 2, 5, 8, 11, 14. And that was indeed what we got. A sub 1 we got 2, A sub 2, we got 5, 8, 11, 14, and so forth. So that turned out to be the correct answer for that one. So remember, when you're doing recursive sequences, you have to put in your function here, but the other part of the function, this u sub n minus 1 part, or whatever it is, it might be u, well, it might be u sub n or u sub n plus 1. It has to be whatever you're interested in doing here, depending on how your function is defined. And so you put that in, and then you go to the table to see the results. And the n minimum, this u sub n minimum, is the first value they give you for a sub 1. Okay, lastly, I wanted to do sums. So let's do 39 for that one. Problem 39. I'll reset the calculator again. Okay, to do sums, you want to take basically it's taking the sum of a sequence. So you go back to list, but here you go over to math, and you see that you have sum down here at 5. So you select that, and then you go back to list again, and this time you go to ops, and you select sequence. So you'll end up taking the sum of a given sequence. Okay, 39 was k from 1 to 5 of 5k plus 3. Sum of k, or the sum from k going 1 to 5 of the sequence 5k plus 3. So in here we're going to put our sequence part of it, which is going to be 5x plus 3. That should have been an x there, not a time sign. 5x plus 3. And again, we put in the same sort of indexing values. We're indexing the variable x. We're going from k equals 1 to 5, and we're going to do it in steps of 1. And now it's exactly as you would have entered a sequence, but instead of just displaying the elements of the sequence, it's going to sum up all of those elements and give you the answer. So for this one, for 39, we got the answer 90. Let's see if we get the same thing. And indeed we do. So that's basically how you do it. Not too terribly hard. If you're interested in learning more about how to do it, this particular website sort of explains all of the entry features and how to do it. So this might be of use to you as well, going through this website. It shows how to do sequences, recursive sequences. I'm not so sure it shows how to do sums, but oh yes, it does down here at the bottom. So you can do that as well. So that's about it.